So I will explain shortly how are we produce sound. In general, the mechanism for produce human voice can be divided into three parts, that are lungs, vocal cords, and articulator. For the first, the lung must generate that airflow adequate and for air pressure, vibrating vocal cord sound. Vocal cords cut off the airflow from the lungs into sound pulses, form the source of the laryngeal sound, and the muscle of the larynx adjusts the length and tension of the tap sound for smoothing, tuning, and tone. Articulator, which consists of the tongue, cheeks, lip, etc., that will articulate and filter sounds coming from the larynx. And finally, came the voice from our mouth.
Why helium can change the sound? First, you must understand how vocal cords work from my friend's explanation. Usually, the sound waves your vocal cords produce travel through air in your voice box, but when they go through the helium that you have inhaled, they travel about 3 times faster. That's because helium is so much lighter than air. When sound waves speed up, but their frequency stays the same, the wave spreads out. Depending on its unique shape, your voice box naturally vibrates when certain wavelength hit it. When sound waves are stretched out, because they are traveling through helium, lower sounding wavelengths get so long that they don't fit right in the voice box anymore. So your vocal tract doesn't vibrate and amplify the tone. The higher tones, meanwhile, are stretched out, so they are the perfect size to be amplified. Inhaling a little helium won't hurt you in small amounts, but it's better not to breathe in much because helium prevents oxygen from getting to the brain.
I'm gonna explain a little bit about our hearing process. So how do we hear the sounds around us? First, in the outer ear, the auricle collects the sound waves around us into the ear canal where the sound is amplified. The sound waves then travel towards a flexible oval membrane at the end of the ear canal called eardrum or tympanic membrane. Sound waves cause the eardrum to vibrate. And then, in the middle ear, the vibration from the eardrum set the ossicles into motion. The ossicles are malleus, incus, and steps. The ossicles further amplify the sound. The tiny steps bone attached to the oval window that connects the middle ear to the inner ear. In the inner ear, the sound waves enter the inner ear and then into the cochlea. The cochlea is filled with fluid that moves in response to the vibrations from the oval window. As the fluid moves, 25,000 nerve endings are set into motion. These nerve endings transform the vibration into the electrical impulses that then travel along the 8th cranial nerve or auditory nerve to the brain. The brain then interprets these signals as sounds, and that's how we hear.
Okay, my friends, at this situation, I will explain about the mechanism of the microphone. So, before we start, I will explain about the definition of the microphone. So, microphone is one object that has relationship with waves. Common component which is in the microphone is like this. I will show the picture in this on this side of the video. If you have seen the picture, I will explain how microphone works with waves. So, first, when we speak, our voice will form sound waves and go to the microphone. After that, in the microphone, this sound wave will hit the diaphragm, which consists of a very thin plastic membrane. The diaphragm will vibrate according to the sound wave it receive. After that, a coil of wire, or we can call this a voice coil, located on the back of the diaphragm, will vibrate according to the vibration of the diaphragm. So after that, a small permanent magnet fixed that is held by the coil. The coil will create a magnetic field as the coil moves. And after that, the movement of the voice coil in this magnetic field will generate an electric signal. So after that, the resulting electrical signal flows to an amplifier or voice recorder. So this is the explanation. Sorry, it's too long.